Okay, so hi everybody. I am Lorenzo Bonetti, and I'm from Group 3, and our robot is called the Puffermantis. Okay. So let's begin the presentation. So Roberto.
Hi everybody, I'm Roberto da Commare, and I'm studying automation and control engineering, and I'm in Rome now. So I developed the sensor, the actuators, and the mechanical structure mainly.
Hi everyone, I'm Gerlando. I am from the Master of Science course in Computer Science Engineering at Politecnico, and I have a bachelor degree in Computer Science and Telecommunication Systems. I'm currently in Palermo, so I'm not in Milan. I couldn't develop the robot. We developed from distance.
Sorry, Lorenzo, you're muted. I muted you. Lorenzo, your mic is muted.
Good morning, everybody. My name is Xin Tong and come from China. I'm a fashion designer and start to study fashion design from undergraduate. I developed the robot working from China. For this project, my main tasks are the design concepts and drawings, design the dress and achievement pattern.
Lorenzo, non hai il controllo, non hai l'audio. Lorenzo, non hai l'audio.
Lorenzo, non hai l'audio.
Lorenzo, non hai l'audio.
Lorenzo, your mic
Microfono.
is muted.
Ok, si vede tutto? Ok, okay. Can you hear me now, the others?
Yes, we can hear you.
Vabbè. We took inspiration from two animals, the pufferfish and the prey mantis. For the prey part, we have chosen the pufferfish because it's a very fast fish, and it has a quite unusual defense strategy. It inflates his belly to become bigger and scares the predators, and that doesn't want to be stuck with the fish in their throat. The praying mantis. The praying mantis is one of the most deadly predators in the planet, and it has a triangular head that can rotate 180 degrees, so it has a very good eyesight, and it has two forelegs. With them, it can grab the prey and kill the other robots. Okay. First plans. Okay. We decided to use the pufferfish for the prey part, so to defend from other robots. We decided to inflate as well and our belly and reject our enemies. For the attacking part, we use the attacking mechanism of the praying mantis. So we will use two arms to grab the other robot's target. Location detection. The robot has two ways to orientate itself. the distance sensor, which are in charge to locate the position of the other robots and then defend from them, and the vision sensor, which is in charge to detect the ponder and the other robot's target. The robot, the first concept of this, the robot is wheeled with the body of the pufferfish and the head and the arms of the Puffermantis. These are the cardboard models. You can notice that the final robot is not very different from the initial cardboard models. Okay, mechanical characteristics.
Now I'm studying automation, but my bachelor was in mechanical engineering, so let's talk about mechanics. We want our robot to have 2 arms, just like the Mantis. But instead of using multi-directional, multi-degree of freedom arms, we managed to have 2 arms with only 1 degree of freedom that allows us to extend and retract the arm by using only 1 servo motor. And at the end of the arms, we have 2 hands to close that can be triggered anytime that we touch the target of our enemies. Next. The belly mechanism was an interesting challenge because we want our robot to extend its body, but to do it we use double scissor mechanism that needs a linear actuator. But instead of buying some linear actuators from the internet that they are very expensive and not so easy to find, we decided to print our own by means of a mechanism of a pinion and a rack. And we needed to print it in a stronger material than PLA, and we use PLA with carbon fiber, and using a servo motor like the one of the arms to extend it. Okay, next. Now let's talk about our distinctive features. So everybody needs a color sensor in order to detect the pond. But online we can find only a color sensor more than 10 euros each one. And we would like to have more than one in order to have more chance, more possibilities to detect the pond. But we ask ourselves, it's really necessary to have a color sensor? No, because we need only to detect between the floor and the pond, so between just 2 colors. So we use a diode, that is a photodiode, and a LED that gives the light, and the photodiode that gives us the difference between the color between the dark and the white. So the pond is darker, and we can make a threshold that gives us the idea if we are in the pond or not. So by using 4 of them, we save a lot of money. Next. Another interesting decision was the motion, because we start by looking at the omnidirectional wheel, but they were too expensive and also not very necessary. So we try with the yellow motor beam of the Arduino, but they were too weak for our robot. So we changed our mind, and using only 2 motors, very powerful, we success our goals, and we have a very powerful motors and very easy to command and rotate.
Okay. Emotion communication. The robot has different status, and we decided to use a simple way to communicate our status. So the eyes of the robot can light, and so there are different colors for different situations, different status. Not only the colors, but it has also a speaker, and the speaker will play simple music, 8-bit music, that indicates the status of the robot. Score communication. At the end of the competition, we have to communicate our scores. We decided to use a way that does not interfere with the animal style of our robot. So no LCD screen and no smartphone or other ways, because the smartphone is outside the robot, and we wanted to keep all the communication inside the robot. So we took inspiration from the Abacus, because it has the abruptus can represent every number using different colors, and we already have different colors because we have the eyes. So the communication, the point communication will be done by pulsing the eyes in different colors to represent different numbers. Just for example, number 119 will be pulsed 1 time green, 1 time red, and 9 times white. Also, we have to communicate the different situation when the robot gained and lost point. So we have a speaker, so we will play different notes to communicate different points, different scores. So the C4 will communicate the life points. When the robot plays D4, how many times has drunk, E4 eaten, F4 has been eaten, and G4 inactive.
This is our final sketch. We choose yellow inspired from Pufferfish and green from Matisse, make robot look more real. And you can see we also design elements of Chinese conf garments in our dress. Next page. About fabric to make dress. First, we would like to use lacquer. It's lightweight, stretch up to 5 times its length, but when we prepare to make a dress, it's too soft and thin. So we decided to use space cotton. It has better hardness and thickness, and it's not easy to deform, can restore the orange shape. About dress shape, we designed that the front and later parts of the pufferfish body will be retracted when both sides extend. But there is a problem here. This design will lead to the design of the front comfort style dress to not be glide. Chinks in the front part will destroy the front dress. After discussion, we designed a new shape. We would like to divide the body into 2 parts. The front part is fixed and the later part could be extended and retracted as needed. Next page. The front part is fixed by an arrow wheel to keep shape of a collar and placket design of comfort style. To easily putting on and taking off, the textile is fixed on the iron wheel with 5 snaps. The side of the sleeve could be opened or closed by 3 snaps. And there are 3 Chinese decorative knot clasps on the front of the dress to close. The later part could be extended and retracted as needed. The supporting structure of the later part consists of 4 iron wheels, which start from the target and connect to the bottom tensile structure. Iron wheel could guide the textile to change shape, expand, or retract. The textile in the later part will be longer than itself to cover a part of the front part to have a good look. Next page. Okay, crowding dress structure. We try to do a dress models, and then we complete the dress pattern in order to make final dress better. Next page.
So this was the initial design, but the problem is that our fashion designer was in China. So we had to simplify the final design to become easier to produce from who has produced the dress, my mother. And then this is the final design.
Okay, for continuous coding, we decided to write an Arduino library for each type of component that is on the robot and for our main board. Here you can see the list of the main libraries that have been developed. And in particular, we have these libraries. So one of the most important is the motors library that allows us to control the robot in a simple way, in very high level, sending simple commands like turn by this angle, go forward, stop after a given amount of centimeters. We also have the color sensor libraries that queries all or one by one the color sensor that we built and returns the color that we expect. So it returns true or false if the color that we expect is effectively did that. And also another important library is the Puffermantis definitions. They give us a configuration file library that not only contains some important values like the life points or the thresholds for all the obstacle avoidance algorithms and all the main code, but it also contains some methods that are important for the gaining or decreasing of the points, of the main points. Such a structure allowed us also to, next, okay. We also have a sound manager library on the Nano board. That is the board that is in charge of the motions, on the communication of the motions, and it plays music and blinks the LED. And such a structure made us possible to have a manageable code, reusable code, so it can be used also for other projects. And the flow of the main algorithm can be easily understood because in this way the main code is really, really short, because all functions are simple lines. Okay, in our robot there are three main boards. The first board is the SP32CAM that is in charge of the object detection algorithm. So these objects are detected through this algorithm, and the SP32 sends some message to the Arduino Mega board regarding the position of these objects. The Arduino Mega board then, with this message and the outputs that comes from all the sensors on the board, computes the algorithm, so takes decisions, and also computes the points that are gained or lost during the challenge. A new message is sent to the Arduino Nano, and it communicates points. So the Arduino Nano, based on these messages, can blink LEDs or play music. Of course, such a structure of communication requires a high synchronization, because all the messages have a predefined format, and the format must be respected. So we had to make sure that the messages was consumed in a certain moment. So we had to manage the synchronization between all these messages. Another important step in our robot is the camera programming. So we used an SP32 CAM, not a simple hardware to work on. So we began with a recursive blob detection algorithm that encloses an object of a given color inside a box. And it was quite precise. The problem was that on the SP32, it was too heavy due to the memory consumption, main memory consumption, since it was a recursive algorithm, and also it was slow. So we decided to skip to another version of this algorithm that was an iterative blob detection object. Sadly, even though we thought that this could be a solution, it wasn't, because we also had problems with memory for the SP32. So we had to rely on something that was simpler, but sadly it was not so effective. It was a little approximative, but it worked, and was a sector density estimation algorithm. So we divided the image in sectors, and we estimated the percentage of the presence of pixels of a given color in each sector. Then we estimated the average position through a weighted mean for the object. So at the end of the design phase, we had a little brainstorming. We said, okay, the place of the competition is a small and symmetrical space. So there is no need of complex localization mechanism, because in fact the place is really small, it's symmetrical, so the things that we have for now are sufficient. Another problem was that we had to battle against the robot, in the sense that we had to gain a good position on the pond. So we had to concentrate on the movements, so fast movements and strong movements. Another problem that, of course, we had to face was the limited budget, since we are a group of 4 members, so we didn't have so much budget. And all these problems led to a decision. That was prefer strength over accuracy of navigation and algorithm. So we decided to put more strength on the robot, on the mechanics, and concentrate on this. Okay.
Okay, robot in a versus period. As you may know, the robot was built in a particularly difficult period, and in particular for our group, I was alone in Milan because our other members were away from Milan. So also the problem of reaching materials and materials that can be easily modeled with tools that can easily found in our home. So we have used a duct for the arms, the plywood, a PVC pipe, a wood stick, screws, a wheel, simple wheel, and a tin of coke. And these are the tools I could use for building the robot. So basically a drill and a saw. And the 3D printer, Roberto had the 3D printed, and the 3D printed parts are the only parts that were subject to forces. The other parts that are not very quite the other parts that doesn't break are not 3D printed and built with a saw. So these are some images of the building of the robot. As you can see, it's basically in plywood and also plastic and simple materials. So main successes. Because I have used such a simple materials, the cost of the robot is very low. In fact, we succeeded in keeping the cost under the 200 euros. And that was a very good success also because we have chosen the sensors and the actuators to save some money and keep the cost under 200 euros, so 50 euros per each person. What is another success of this robot? That it's very easy to build because I have built it with simple tools. So the robot is not good for being sold already assembled because they are not good design materials. But I think the robot is very suitable for being sold in a mounting box for makers who doesn't want to have a already built robot, but want to put their hands in building the robot and also being the structure, so we can sell the robot with only the electronics and the 3D printed part and let the maker who wants to build our robot build it. So this is the final video.
This is Puffermantis, a chimera robot that joins the fierceness of the mantis and the defense mechanism of the pufferfish. It can attack by extending its arms, inspired by the fast and lethal arms of the mantis. These extend if the target is detected by the camera placed inside the head. The head can turn left and right to have a bigger eyesight. The main task is to search the pond using a color detection algorithm running in background. When it arrives on the pond, the Puffermantis stops. If it is attacked or if it's drinking, the belly is extended, simulating the defense strategy of the pufferfish, making the robot difficult to reach or attack. The robot communicates its emotions and its points through the LEDs of the eyes and the sounds of the speaker. Thank you for the attention and enjoy the competition.
Very nice presentation. Okay, very nice. Yes.
Well done, guys. Well done.
Strategy. It's a winner strategy. The competition. Okay. Thank you very much for the presentation. It's very interesting. There are a lot of small. I think small. You say
good ideas.
Yes, good ideas, intelligent, smart decisions. I think. Okay, thank you very much, and let's pass to the next.